So in this video, we'll take the classification of ligands based on the denticity. Previous video, we have taken the classification of ligand based upon the charge, negative ligand, positive ligand, neutral ligands, and we have taken the different types also. Let me take how we classify the ligands based on the denticity. The denticity means what? How many ligands it can donate. That means how many lone pairs they can donate. For example, ammonia, it can donate only one lone pair. Therefore, its denticity will be 1. For example, if I take ethylene diamine, CH2, CH2, NH2. Now, in this case, what happened here? Nitrogens are 2 nitrogens are there. One here, other is here. Now it can donate 2 lone pairs. Now the denticity for this one will be 2. For this one will be 1. That means very simple to understand what is denticity. The number of lone pairs that can be donatable. Not having lone pairs. The number of lone pairs I am not saying. The number of lone pairs which are donatable. See, in the last class also I told you water is having 2 lone pairs. But it can donate only 1 lone pair. Second lone pair cannot donatable. This cannot be donatable. So your denticity is only 1 because it can donate 1 lone pair. Having 2 lone pairs, but donating what? Only 1 lone pair. The denticity for this one is only 1. So denticity means not having number of lone pairs. Denticity means how many lone pairs it can donate. That we need to understand when you discuss about the denticity. Let me see this one now. No. Ligands are already I told you they are what based on the charge, positive, negative, neutral ligands are there. So next, ligands are also classified as based on the denticity, isn't it? Based on the denticity. Let me see this one now. In negative charged ligands, when you see the negative charged ligands, this negative charged ligands example we will get in the previous video. In the previous video we get this classification, negative and positive and neutral. Now negative ligands are classified into 2 types. One is called monodentate and polydentate. Now, monodentate means what happened? Which can donate only 1 lone pair. It can donate many number of lone pairs, many lone pairs. Maximum, most of the case it will be 6. Most of the case it will be 6 only. Okay, right. For neutral ligands, again monodentate and poly, same classification. Because in most of the examples you are observing either negative or neutral. Positive are very few. One is what NO2 plus, other is what something NO plus. Isn't only 2 are there. So negative and neutral, they are classified into 2 types. One is monodentate, other is what polydentate. Otherwise bidentate, tetradentate also we can say. So polydentate may classify into bidentate, tridentate, pentadentate, like that. Now let me see monodentate negative ligands, which are called monodentate negative ligands. All of you observe now. This is all are what negative ligands. See, all are having what? Negative as a charge. All are negative ligands. They are what? Negative ligands. All are having charge like this. You observe here, all are having charges. No? Now, nomenclature also we discussed in the last video. Cyanide called as cyano. Halides are called fluoro, chloro, bromoide. They are IUPAC nomenclature. H minus hydride ion called hydrido. O comes actually. When it is negative charge, O comes. When it is positive charge, comes. IUM. For positive charge, comes actually, right? Now this is called nitro because the ligand donating from nitrogen side, not from oxygen side. No, that is the reason you have to call nitro N. Now ligand is donating, the lone pair donating from the oxygen side, therefore nitrito O need to come. That means what is the meaning of this one? Oxygen donating the lone pair, a nitrogen donating the lone pair. That is only the difference. Okay, they are called ambidentate ligands. I will discuss this one. What are ambidentate ligands? In the next video we get that now. Nitrato, hydroxo, amido, all are having only 1 lone pair they are donating. This negative charge is what? Donating actually. 2 electrons they are having here. This negative charge is having what? 2 electrons. Here also what happened? Negative charge is donating from 2 electrons. Isn't? But the from the oxygen side. This one is from nitrogen side. Remember that. Fluorine, negative 2 electrons. Chlorine, 2 electrons. 2 electrons is nothing but what? 1 lone pair. This is the lone pair. So all are donating only 1 lone pair electrons. Therefore, they are called monodentate ligands here. Understood here? This is very, very important. Monodentate ligands, they can donate 1 lone pair only. Next, polydentate. In polydentate, first of all, we'll see bidentate. Bidentate means what happened? It can donate two lone pair of electrons. It can donate what? Two lone pair of electrons. First example, oxalate ion. This is called oxalate ion. We have already comes in this one in the negative ligands actually. Oxalate ion. The name we are giving here, oxalate. We are giving. Next one, acetyl acetonate. ACAC generally we use shortcut ACAC. Acetyl acetonate. This is acetyl group. This from up here it is acetyl. Now this one is called acetonate actually. Okay, so acetyl acetonate. Simply we can call acetyl acetonate as ACAC, isn't it? When you are writing the formula, you can write ACAC also. But nomenclature must be acetyl acetonate. Now you see, observe here what happened. Now how many ligands are there here? You see one ligand here. Negative indicates one lone pair. The next ligand from the oxygen lone pair. Now this is the lone pair given from the oxygen here. Now how many lone pairs are again? Two lone pairs. Bidentate ligand. Next will be take glycinate ion. Glycine is amino acid. Okay. Glycinate ion in which you're having one lone pair here. I will show this one. Here it is lone. Next one, negative charge. Negative also called lone pair electrons. Negative is nothing, two electrons. So how many you are getting? One from here, second from here. Therefore, what happened? It is called bidentate ligand. So bidentate ligand means a ligand which can donate two lone pair of electrons. They are called what? Bidentate ligand. Isn't the name you are calling as glycinate or GLY? Generally, the formula we can write instead of writing everything like this. Simply you can write GLY. When you write like this, nickel GLY taken 3 times, isn't it? Writing what here? Something what? -4 something. GLY means glycinate. Instead of writing everything what happened, we can write GLY. Formula also we can write in the form of. Now, anybody in the online, can you say what is the coordination number of nickel here? Anybody online? What is the coordination number of nickel now? Vaishnavi is there online. What is the coordination number of the nickel? Many of them are there. What is the coordination number of nickel? Anybody? Possible? No problem. Right, we'll say this one. See. Glycinate is donating how many lone pairs here? 2 lone pairs. Okay. Now I have taken here 3 glycinates and each one donating how many? 2 lone pairs. Total how many lone pairs are there? 6 lone pairs. Therefore, denticity will then coordination number will be what here? 6 here. That means if bidentate ligands, this is very important one. The bidentate ligands, if you are having 3, the coordination number becomes what? 6 here. Okay, 3 into bidentate ligand. 3 into bidentate ligand is equal to coordination number will be 6. This is the coordination number, isn't it? It's very, very important one. Very simple one also. So these are something what? Negative ligands which are having bidentate nature. One is called oxalato, other is acetyl acetonato, second is glycinato, isn't it? Right. Next. Next, we'll take something pentadentate ligands, pentadentate, which are very, very important. That only we discuss. Many are there, but which are important, we see this one. Pentadentate means what? How many lone pairs we are having? 5 lone pairs we are having. 5 denticity is equal to 5. It can donate at a time 5 ligands actually. Now you observe here nitrogen, 1 lone pair here. Second lone pair on nitrogen. Each negative charge is nothing but 2 electrons. Isn't it? Now total how many we got? 5. So 5 you got actually. The name is called ethylene diamine triacetate. Now why you are calling ethylene? See, 2 carbons are there. 1, 2. These are what? These 2 collectively called as actually ethylene. It is called what? Ethylene. Ethylene it is. Now how many amines are there? 2 amines are there. Therefore it is called what? Diamine. Diamine it is. Next, triacetate ion. How many acetate ions are there? 1, 2. Next, what happened here? 3. Therefore, it is called triacetate ion. We can call this one. So, ethylene. This one is ethylene part. This one is diamine part. This one is triacetate. Oh, isn't it? So, this is called pentadenticity. Now, hexadentate means you just simply do put here what happened. One more acetate group here. Now, put here what happened. one more acetate group here. That is called what? Again, ethylene. This is ethylene part. Diamine tetraacetate. So simply we are calling EDTA. EDTA we can call this one. Ethylene diamine tet. In writing the nomenclature structure also we write like this: calcium EDTA. Calcium EDTA. Isn't it? Here you can write what happened, -4 we get here, you will get +4, then you can write -2 here. Now this is called calcium EDTA. If anybody online, can you say what is the coordination number of EDTA? Coordination number of EDTA is here. EDTA coordination number will be, denticity is equal to how many? Denticity is equal to how much it is? 6. Therefore coordination number also what happened? 6. So coordination is number is nothing but what? Denticity only, isn't it? So denticity, coordination number is nothing but called denticity only. Next, the name of OH minus ion is complex compound. What is the name we are using here? Which name we are using here?
Hydrogen ion,
hydroxide ion. OH minus is negative charge. Therefore, ide we can take. Hydroxide. This is the IUPAC nomenclature. Hydroxide ion it is. Very good. Hydroxide. The name of OH minus ion is hydroxide ion. Hydroxide ion only we can. Hydroxide ion. Generally, hydroxide ion we can call this one. Hydroxide only. Hydroxo, chlorido, bromido. Okay, sometimes it may call hydroxo also. Hydroxo also we can call sometimes. Generally, we call hydroxide, sodium hydroxide, NaOH. What we call this one? Sodium hydroxide. So, in short, what happened? It may, to make a simple nomenclature, then you can use hydroxo, but hydroxide also correct one. Right. Ethylene diamine is what type of ligand? Ethylene diamine. Ethylene diamine. So ethylene diamine, in the last class we have taken that one. Neutral ligand we have taken. No problem. I will write again the structures. This is called what? Ethylene diamine. You will get in the neutral ligands in the last video. This one. Now this is structure. This part is called what? Ethylene. This part is called what? Ethylene. How many amines are there? Here one amine. The second amine. Therefore, it is called diamine, ethylene diamine. In short form, it is called EN. In short, it can call EN. Now, ethylene diamine, definitely how many lone pairs you are having? 1 and here. So, what will be the answer here?
Bidentate.
Very good. Bidentate ligand it is. Now, what is the coordination number of cobalt in this complex compound? What is the coordination number of cobalt here? Yes, coordination number of cobalt. Just now you told me ethylene diamine is bidentate ligand. Now, one ethylene diamine is equal to how much ligand capacity is how much? Denticity is equal to how much here? 2. Density is equal to 2. Denticity is equal to 2 here. Now, how many there are? 3 there are. 3 here. Now, each one is having 2 as a density C. Therefore, it is having coordination number is equal to 6. This type of questions also you will get in examination. Next, we'll see the neutral ligands monodentate here. Neutral monodentate ligands here, which are having what? Negative charge. Now, let me see here ammonia. These are not having any charges. If you observe, they are not having any charge, but they are having a lone pair here. They're having, I'm writing only one lone pair here because there are 2 lone pairs are there, but only one lone pair is donatable. So monodentate ligand. Nitrosyl oxide also having a lone pair here. Carbon monoxide is also having a lone pair here. Here also you can write a lone pair here. Carbon sulfide you can write a lone pair here. Phosphine also we can write the lone pair. Phosphorus also we can write the lone. Here it is a thiourea. Here also lone pair is there. This comes under what actually? See. Thiourea you can take a bidentate ligand. This one you can take a bidentate ligand. Sometimes what happen, some ligands can act as a monodentate also. See, water is having 2 lone pairs, but donates what? Only one. Sometimes some bidentate ligands can act as a monodentate also. But generally it comes under bidentate ligands because 2 lone pairs are there here and here. comes under like this. So all are called what? So you need to remember what actually nomenclature. This is the nomenclature: amine, aqua or aquo, nitrosyl, carbonyl, thiocarbon. Thio means whenever if you get in the place of oxygen, if you get sulfur, no? Wherever if you get sulfur, that is called thio. So thiocarbonyl you can call. Phosphine, triphenyl phosphine. Why? Because there are 3 phenyl groups are there. 3 phenyl groups are there. C6H5 means nothing but phenyl group. So triphenyl phosphine. Urea formula is actually NH2CONH2. This is the formula of urea. So in the place of oxygen, what we got? Sulfur. So what we use? Thiourea to call this. So these are the actually some of the neutral ligands. Next, bidentate ligands. Ethylene diamine, just now we discussed this one. Ethylene diamine, just now we discussed this one. We don't have any charge, therefore it comes under neutral ligand here. But how many lone pairs are there? One here and other is here like this. Therefore it is denticity is equal to 2 bidentate. Now dipene is nothing but actually pyridine actually. So in shortcut they will call dipy. When they write structure name, no, they will write like this. For example, cobalt, dipy, they write like this. Taken what? 3 times like this. So instead of writing 2 comma 2 dipyridyl, they write what? Dipy something like this. Okay. The nomenclature we are using dipyridyl here. Now we have one lone pair here. Now one lone pair. Now this will donate to the metal complex compound actually. Now orthophene we can generally call this one. In short form it is called orthophene. Orthophene we can call. Orthophenanthracene, that we can call orthophene also. Phenanthralene we can call orthophene. Ophene also sometimes they will use actually. Now it is also having bidentate ligands actually. Next, tridentate, let me see. Tridentate means denticity is equal to 3. Your denticity is equal to 3. Now the name you are using diethylene triamine. Simply we can call diene. I want to write something like this. Nickel, diene, taken 2 times. So when you're writing the formula, I'm using diene here. Instead of writing diethyl triamine, isn't it? I'm writing simply diene. Diene is nothing but diethylene triamine. Now diethylene triamine, how you got this name? You see. How many ethylene groups are there here? One here, one ethylene group here, second ethylene group here. There are 2 ethylene groups are there. 2 ethylene groups nothing but called diethylene. How many amines are there? NH groups. 1, 2, 3. There are 3 nitrogens are there with NH, single bond nitrogens are there. Therefore, they are called NH also called amine only because it has single bonds only. So triamine, 3 amines are there. Therefore, triamine. Diethylene triamine also called diene. So nomenclature, when you are writing the nomenclature, this is structure we are writing. This is structure. When you write IUPAC nomenclature, you have to write it is diethyl triamine. Compulsory you have to write diethyl triamine, isn't it? So here it is having how many lone pairs? Let me see now. The lone pairs it is having here. Here it is 1. That means donatable lone pairs. Donatable lone pairs are 3. Therefore, tridentate ligand it is. Next. One more neutral ligand, tetradentate ligand. Tetradentate is called triene here. Simply we can call triene. Triene is nothing but 3 ethylene groups are there. 3 ethylene. In the previous case, 2 ethylene groups are there. Now you are having 3 ethylene. See, 1 here, first ethylene, second ethylene, third. 3 ethylene groups are there. So triethylene. How many amines are there? You see, 1, 2, 3, 4 amines are there. Therefore, tetraamine. Triethylene, tetraamine you can call it. Simple structure you can write triene like that. Nomenclature will be triethylene tetraamine. Now let me see how many denticity of this. What is the denticity? 1, 2, 3 and what? 4. The denticity is equal to what here? 4 actually. Here it is. And here it is. 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 So denticity is equal to 4. It is a tetradentate ligand actually. Comes under polydentate. Neutral ligand. The important thing is these are not having any charge. Right? Now, which of the following is a tridentate ligand? Anybody? Which is the tridentate ligand?
Diene.
Let write. I will write. You just speak out. I will write ammonia structure. I will write all the structures. You can speak out. No problem. Ammonia, monodentate. Right. Triethylene. Triene means what? Triethylene, triamine. Like this. Triethylene means CH2. You can write. If you don't know, you write like this. Write 2 times ethylene. Triene means what happened? Triethylene. Write down like this: CH2, CH2, CH2. If you get any doubt, write down like this. In examination, it will be easy for you. Triene means what here? 3 times. Tri means what? 3 times. You have write ethylene groups. One ethylene group, second ethylene group, third ethylene group. Now put here at last NH2 here. Put all NH2s like this. Put here also NH2 here. Okay. Next, between also put one NH group here. Between also put one NH group here. Okay. If it is a terminal, write NH2. If it is a bridged one, write NH. Now count how many here? 1, 2, 3, 4. Now it is tetradentate ligand. Tetradentate. No need to buy the things here. Triene means it is tetra, triene, tetra, triene, tetra. You no need to buy like triene. Write down like triethylene. Tri 1, 2, 3. Triethylene. Now put at the terminal one NH2 group here and NH2 group, and between NH groups. In this way, we can get easily, right? Dipyridine. Just now we've taken the dipyridine. Will have 2 pyridine groups like this. Then just now we've taken this one. One lone pair here, one lone pair here. Only 2 lone pairs are there. So denticity is equal to here 2 here. Next, diene. How to make diene? Diene means 2 times. Which one you have to take? Ethylene. Ethylene group you have to take 2 times. CH2 like this. And again CH2. 2 times completed. Diethylene means 2 ethylene groups. Next, what happened? Put at here terminal NH2, again terminal NH2, and middle put what? NH. Terminal and between also you have to put actually. So now how many? 1, 2, 3. Therefore, tridentate ligand. Answer will be what here? Diene actually, isn't it? In this way we can write. No, don't buy diene, triene. Triene is 4, something like that. Okay, right. This is about actually the denticity classification based on the denticity. Now let me move to next to one more classification. I stop this recording.